Hello and welcome to today's class for Chemistry for Beginners. As always, we are going to be very detailed in whatever we do. Today we'll be talking about volumetric analysis, and under this we are going to be talking about titration. Of course, this is going to be part 1 because it's a very wide topic and we are going to have it in almost 3 parts. And in this, before we go on, I would like you to please subscribe, share, like, and comment, as this will go a long way to support us in what we do. Due to the technical nature of this topic, I intend to give you a very short story that would make you understand this topic. Meanwhile, I want you to be very patient, very patient to follow the analogy till the end. Imagine that we have a house, and then in this house, we have people inside it. And we need to know how many people are inside. More like talking about the concentration of either the acid or base down. But to continue the analogy, I want you to consider that we also have what we call rules. That's the rules of the community that guides what they do in the community, which in our chemistry we call equation of reaction, how the acid or the base would react. Let us assume that men are acid, and then women are going to be the base, obviously. Now, look at the women, they are the base. Now, if the men are going to get married to the women, the rule of the community is what they must follow. Now, for us to know how many men will be able to marry how many women, we need to know the rules of the community. So, in this our analogy, in this our example, the rule of the community is we have ratio 1 to 2. That is, one man marrying 2 women. Now, that is, yes, that's the man on the screen. One man who is going to marry 2 women. That is the rule of the community. Now, consider the first man going into the house to go in and marry the women. He was able to come out with 2 women. So we can guess that there are 2 women in there. A second man goes in, and if he comes out with another 2 women, we can now say, oh, that means there were up to 4 women in there. When a third man goes in and comes out, we can also assume, oh, maybe there are up to 6 men in that place. Then now, when a fourth man goes in and comes out yet again with 2 women, we can equally say that there are up to 8 women in that room. But when the fifth man goes in and comes out empty-handed, at that point, we can say the women in the room have finished. That means there are no more base left. The acid going into the base, reacting with the base, so long as there are more women there are more base in that place, the acid will continue to react. There will be no color change. But as soon as there is a color change, it means you have come to the end point of that reaction. The total number of women or the base in that house have all been picked up, or in this our case, they have been neutralized. This, in summary, is what we do in volumetric analysis, titration to be specific. We have the acid, we have the base, they have concentrations, we don't know their concentrations, we need to know. So all the work we do revolves around things like this. But before we move on, there are some very important things I would like you to understand. I would like you to know before we start driving forward in this program. We have apparatus that we use. We have terminologies that we use. I want you to first of all understand those things before we go in depth. Among the apparatus that we use, the first one I want to introduce to you is the retort stand. The retort stand is what we normally use to clamp the burette and make it stand vertically. This is the burette. The burette stands vertically. It is graduated, and it is used to measure the volume of acid used. This is the pipette. The pipette is used to measure the volume of the base. You can see it has a lobe in the middle. That's what will differentiate it. You can see this is the conical flask. The conical flask is mostly used in titration. It is made specifically so that when you shake, the acid or base will not pour out. This is the beaker, mostly used again to measure. There are different sizes of beakers and conical flask. Now, I would want you to please calm down and follow these few calculations I want to show you ahead. You are going to need them for the serious work we are going to be doing ahead. The 3 very serious concentration terms are, number 1, the amount, which is usually calculated by putting the mass and divide it by the molar mass, the unit is usually the moles. After then, we have the next concentration term, which is the mass concentration. The mass concentration is the mass in grams divided by the volume in dm cubed. The unit is usually grams per dm cubed. After then, we have a third one that is called molar concentration, which is usually calculated by dividing mass concentration by molar mass. The unit is usually moles per dm cubed. Let's now take a good look at these concentration terms one after the other and take one or two examples and solve them in order for us to appreciate it more and understand it better. The first example will be on amount. Calculate the amount of NaOH present in 20 grams of solution. Now, take a look at the molar mass of NaOH. I assume by now you should have known how to calculate molar mass. The mass of sodium is 23, mass of oxygen is 16, mass of hydrogen is 1. So, 23 plus 16 plus 1 gives us 40. Now, the mass of NaOH is 20 grams. This was given directly in the question that we read earlier on. You are free to, at any time, go back and cross-check any of these figures. Now, if the amount N, which is mass over molar mass, simply means we're going to say 20, which is the mass given, divided by 40, which is the molar mass, and that will give us 0.5 moles. Take note that units are very, very important when it comes to the second example. Calculate the amount in moles present in 5 grams of H2SO4 tetraoxosulfate 6 acid. Now, molar mass of H2SO4 is 2 times 1. Don't forget hydrogen is 1, but there are 2 of them, plus 32 plus 16, which is the mass of oxygen, times 4, because there are 4 of them. Everything will give us 98. Mass of H2SO4 is 5 grams. Of course, this also has been given in the question. So, going by our formula, amount equals mass over molar mass. That means we're simply going to put 5 divided by 98. That will give us 0.05 moles. Like I said initially, units are very, very important in this topic. Let's now take on mass concentration. Example 1. Calculate the mass concentration of 10 grams of Na2CO3 sodium carbonate when dissolved in 250 cm cubed of distilled water. Now, let's take on this calculation. We have to learn how to convert cm cubed to dm cubed. 1000 cm cubed is equal to 1 dm cubed, meaning that if we have 500 cm cubed, we will say 500 divided by 1000. That will give us 0.5 dm cubed. So in our question that we have 250 cm cubed, converting it to dm cubed, it will mean 250 divided by 1000. That will mean 0.25 dm cubed. That now is our volume of our solution. Now, mass of Na2CO3 is 10 grams. This, of course, is given in the question. So, if we're going to calculate mass concentration, we're going to say 10 divided by 0.25, that is the mass divided by the volume in dm cubed. That will give us 40 grams per dm cubed. Feel free at any time to go back or pause in order to understand everything we do. Example 2. Calculate the mass in grams per dm cubed when 20 grams of HCl is dissolved in 300 cm cubed of distilled water. Going to the solution now. We have to convert 300 cm cubed to dm cubed, meaning we'll divide 300 by 1000. When we do that, we are going to get 0.3 dm cubed. Having gotten that, we are going to now impute this into the general formula. But of course, before we do that, we are going to know that we have been given the mass of HCl to be 20 grams. Knowing that, we're going to now input this into the general formula, which means we say 20 divided by 0.3. When we press our calculator, we're going to come out with 0.67 grams per dm cubed. That is the mass concentration. Now, let's take a look at another example. Calculate the molar concentration of a solution of HNO3 that was prepared by dissolving 10 grams of the acid in 400 cm cubed of distilled water. Looking at this, we need to know the molar concentration now. Molar concentration is mass concentration divided by molar mass. The unit, of course, is moles per dm cubed. Then, if you look at the slide in front of you, we have converted the 400 cm cubed to 0.4 dm cubed. That is dividing it by 1000. And we have taken note of the mass, that is 10 grams of the acid that was also given in the question. Going further, we are going to divide that 10 grams by 0.4 dm cubed, which is the volume. That will give us 25 grams per dm cubed as the mass concentration. Now, getting that, we need to get the molar mass of HNO3, which is 1 plus 14. That's the 1 is the mass for hydrogen, 14 is that for nitrogen, plus 16 times 3, which is the mass of oxygen. Everything is 63. Molar concentration, therefore, will be 25, which is the mass concentration, divided by 63, which is molar mass. That will give us 0.397 moles per dm cubed. Taking another example, calculate the concentration in moles per dm cubed when 5 grams of NaOH is dissolved in 150 cm cubed of solution. Now, we are going to calculate the mass concentration, which is going to be the mass divided by the volume in dm cubed. If you notice the 0.15, we have converted the 150 cm cubed to dm cubed by dividing it by, with 1000. Now, going further, the molar mass of NaOH will be 23 plus 16 plus 1. Don't forget, those are the molar masses of the 3 elements present there. Altogether, we are going to have 40 as the molar mass for NaOH. Therefore, molar concentration will now be 33 divided by 40. That will give us 0.825 moles per dm cubed. That is the molar concentration of this solution. As we come to the end of this class, I would like you to please subscribe, like, share, and comment in order to boost whatever we are doing. Support us by your likes and your subscription. Thank you. And I want to specially dedicate this class to my comrades, Fego class of 1995. Thank you for the support. Thank you for all you do. I appreciate. God bless you all.